is Juan Montiel Nelson from Spain. Juan is author of 100 papers and received the Best Paper Award in some conference. The main interest includes very high-speed integrated circuit design and optimization of digital integrated circuit. Please.
I will start. I'm starting the presentation.
Yes,
and
Marco,
we do it together. We do it together. We do it together.
Okay. Marco Ottella is
Yes.
well known.
So
Should I speak here or there?
okay. This is it. No, maybe you take this and I take this one. So so I start with a question which some of you already knows, but I do it again. Do you know what is the most, let's say, dangerous and most diffused disease? Any idea? No ideas? It's written there. Aging. We get old. We get old, and the replication mechanism of our DNA starts to fail. Yeah? We get. So, but it's also true that with a good lifestyle, exercise is important, decent dieting, of course, moderate alcohol and so on. So, stress management. This can make this process of the telomeres. The problem is the telomeres. So the ending parts of our chromosomes that are somehow the checksum of our DNA that starts to get corrupted. And then the replication mechanism goes into failure, and then we get cancer, we get several disease, dementia, and so on and so forth. But I say, with a good lifestyle, this process can be not cancelled, of course. We will die sometimes, but it can be a little bit slowed down. So I hand over now to Juan. Together we made this project making into reality, and he will now explain. This was the basis of the project. He will now explain about this project.
Okay, so, thank you for the introduction, Marco. As you mentioned before, we have a problem that we try to solve it, so we can perhaps solve in future, in long term, when we have a time machine in our body to repair our telomeres. But by now we solve it, but a new initiative, a new way. So the presentation will have a lot of points that you see there. We start with what is the current challenge, objective, some of our markets in that area. How can we integrate the technology that we have, the mature technology that we have, toward higher TRLs, and then we are going to show you one of our technology demonstrators is a 3D tracker, was in air and also in water. You will be surprised that we have a lot of advantage in water, but in another species, not in humans. But I will show you a little bit. So we will go through the heart rate variability, which is like a frequency shifter, frequency measurements of the rate, of the heart rate. And then we will go to intelligent closing texture to integrate the technology and so on. So what is the objectives that we are, well, mainly two of them is first, be able to build a proper ecosystem, because it's a multidisciplinary, interdisciplinary area. Not only we have semiconductor, we are only have the software integration, but also there is life science very close to there, and social too. So, and the other objective is to use emerging technology or create emerging technology that are quite suitable for us, for the humans. So we are talking about wearable sensor technology and a smart textile. So what is the impact? The impacts have a big number of you, but we summarize in two of them. First, trying to transform the future of the remote passive monitoring and revision process. This is because, you know, the age pyramid has inverted, so we are not going to we're not going to increase the investment in centralized building and centralized hospital. We should spread around in a non-centralized way. So the other is how can we utilize the biometric data? What is the source of the biometric data that we have today? How can we build that biometric data to start to making new algorithms we show you. So what's about the markets? You know, the global smart healthcare market is around close to $150 billion with this growth rate of close to 13% till 2030. So it's a good challenge to be there. Also, you have a look to the sport equipment market. Yes, sport equipment market, you will see that the amount is 5 times, $562 billion, with the growth rate half of the previous one. If you have a comparison between, for example, China and Europe, you will see that we are not so far there. So we have some challenge to fit together, even to overcome. It's not the case of the automotive industry, but we have some challenge in health because we are have a lot of investment in health in Europe. So when you have a look to the smart sport equipment market, you will see that the growth rate is the highest, close to 20%. So mainly, I mentioned there, while Europe is leadership for electronic component systems with major players like ST, NXP, or Infineon, we see that we miss significant player in the higher layers of the value chain. It means to start to move algorithms from the cloud to onboard. That we need to onboard because anyway we are not going to make biomarkers or biosensing devices. So one of the projects that I showed is yesterday morning was Xtremion. Xtremion is as a summary. I think that it's not quite clear, but you will find on the website the whole figure. So we have 10 technology demonstrators. Some of them are related with wearable sensors, new emerging technologies, and some of them are classical. I mean, based on the state of the art. Why? Because we found that there is not enough data for a start to get correlation between the new devices who is going to measure a biomarker based on sweat and the blood analytics. So this is the reason that we use state of the art. So there you will find that we not only are interested to provide the technology wearables, technology demonstrator that we call it, but we also want to integrate it on cloud. So but in order to provide digital twins for professionals who wants to know what is the evolutions of your body on the mid-term. So one of the two of the aspects that we have in the project is the activity tracking. Activity tracking is not only related with the movement, but also related with the electrical signal in your body. So on top, we have a lot of application for heart rate variability on the market. Even some of our partners, Curious, are the first company in Europe to provide very good software in heart rate variability. So that heart rate variability is a measurement of the change of your heart rate when you do exercise before, during, and after. So the question is that software is made on cloud, but it's quite difficult to provide enough data to obtain a good performance when you do exercise. So the idea is to start to move that software from the cloud to on board, to the edge. What's the problem? The problem is we don't have enough resource on edge to make such to implement that kind of algorithm. So we should find compromise between cloud and on board. So one of the ideas is to step to move raw data from edge to cloud to do some processing, very clever there, in order to know for each individual what is going to be the variability of their heart rate, with the very simple algorithms to get the frequency, a couple of fundamental frequency of your heart rate variability and send to the cloud. So the information is reduced dramatically. That idea is now in particular for human. We come from another area in which we have a very active metabolisms like the fish. The fish have a very active metabolisms, and sometimes for making measurement about the metabolism of the fish, we need to place accelerometers on the body. They have electrical core, but the water, the salt water is not very good for measurement electrical. So we should find what is the correlation between the heart rate and the movement when they do the respiration. So similar in humans. So this is what I show here is a device. We have a very thin microcontroller, very ultra low power microcontroller from NXP. In that microcontroller, most of the volume, most of the weight is for the battery. But even for the battery, we use it for fish or around 100 milligrams. So, so this is a with the commercial devices. This is a good approach in which they contain algorithms. Now they are running to measurement the perculum movement. From the perculum movement, you are able to correlate the respirations. But you should calibrate it individual by individual, because each individual has its own metabolism. So, what is the advantage that we have in humans? We have a lot of area, because one of the advantages of us is the dimension of our body. We have one of the bigger organs in our body is the skin, so we have a big area. So by combination of testing integrated device, we are going to collect a lot of signals based on physical movement, signals based on electrical, and even from the muscles, electrical myora. So with all that kind of signals.
What is the first topic you learn in class when you need to build any AI algorithm?
Sensor fashion.
Well, the key point is getting excellent data sets. That means huge data sets taken from different people and in various conditions. Only with such diverse data sets, you are on a correct path to create a good algorithm. SD could make your life easier. One single sensor which can collect data, classify and detect interference with smaller datasets and directly on your personal device. Let's explore how the self-learning AI IMU helps you to improve, for example, your fitness training. Miss Clara wants to create a new fitness routine with her personalized device. First, she needs to train the sensor with the movements she wants to exercise. The sensor will immediately learn the exercises adjusted to her movements. After training the exercises, the sensor can detect them or count repetition of each. Customizing your device and teaching the sensor new exercises is a step ahead to become more efficient in your training. But how is that possible? Thanks to a sensor with computing capabilities that are beyond anything we have shipped before. The Intelligent Sensor Processing Unit is a tiny but powerful device with a huge intelligence. The sensor automatically detects movements and recognizes exercises. This is achieved thanks to unsupervised AI technique, accelerometer detecting all the linear movements, and the gyroscope, which helps with the twist recognition. So, what is ISPU in a nutshell? It is a unique self-learning device with personalization features. It is possible to integrate AI for faster and real-time feedback, and it reduces development time, cost, and complexity. If you want to know more about this product, please visit sce.com/ISPU or contact your local SE representative. Talk to you soon.
So what we have done, we have conceived this this project, and we have also joined it with another more targeted for higher so the bringing the existing technology to a higher level, TRL level, which is the Xtremion project in the CHIPS joint undertaking. So to bring to TRL 6 and 7 the existing technologies, but also to develop some other, let's say, less mature technologies within another Horizon project. And in particular, the key, as you have seen in the video, is the artificial intelligence behind. So forward learning techniques, unique and new techniques supporting multi-parametrical analysis, for instance, as we have seen for complex movement, but also to combine several biomarkers to understand better what is happening in our body. So, for instance, to measure our glucose starting from the parameters that you can get, for instance, from the sweat. And this is what we are doing in the EU Trains project, also to develop techniques for transmitting data underwater in real time and with zero latency, and to integrate them into the fabrics, into the garments. And last but not least, microfluidic sensor with non-invasive approach. So, as you have seen in the timing machine learning, I don't go in details on this because we have seen the video is quite clear. But of course, the forward learning is one of the keys. So from the edge back to the cloud and back to the edge. Body area networking, so to combine different transmission techniques and different transmission media to have a better and more stable real-time connection. Also, again, using artificial intelligence to combine them. Integrating them into the fabrics with printing techniques for timing circuits in textiles and hybrid electronics printing. And last but not least, microfluidic sensors for non-invasive analysis of biomarkers. But one of the important aspects that we are pursuing in this project is the participation, multidisciplinary participation, so not only technicians, but experts in medical disciplines, experts in sport disciplines, experts in psychology, sociology, and so on. And last but not least, the participants, so the users, that the patients on one side, the sportsmen on the other side. So to bring them inside the design loop, and of course with the supervision of clinicians, psychologists, sociologists, and so on.
Okay, I think that it's time to finish we should go to the conclusion because otherwise. Well, that's two initiatives are two projects. One is Horizon Euro, the other is also Horizon, but under GPO you're taking. One is related majorly with technology, and the other is with algorithms. We have some convergence in some of the subjects. We invite you to follow our dissemination and communication initiative that's we have in our wallet now. The presentation here today, and also the next presentation for the field and exercise. So thank you for your attention. I'm sorry for the delay perhaps for the time.
Thanks a lot for your presentation. And it was perfect, the timing, because we saved a lot of time before in the presentations before and could use it for your interesting presentation. So, are there any questions? Then it's again, you've got it. Sorry.
Yes, thank you very much. It was very exciting. About the wearable technology, let's say from hardware perspective, where do you see, let's say, any electronic components taking the harsh, let's say, washing and heating and cleaning cycle? I mean, how durable or robust the electronics need to be in order to have, let's say, some usable lifetime in wearable devices?
Yeah, there is two open issues. Is one the robust. From my point of view, the knowledge is high robust. Nowadays you will find a lot of devices, microcontroller, that can switch off, can turn off the outputs, the connection outputs. You can it can work thoroughly underwater and so on during long terms. So I have some experience for making long-term experiments underwater. We have one of our bottles to measurements body lines movement that was programmed in the seals, but the microcontroller works during 100.
I understood the microcontrollers can be separated from the circuit, but let's say something that was also in the presentation, probably fabric interwoven electronics. So that is probably not so easy to detach from.
Well, yes, but concerning the fabrics is the interconnection. So what it is important is to have the interconnection between sensing devices and computation devices. Sometimes we have some computation on the mixture. There is the complete mix.
Okay.
So so for what concerns the electronic components itself, we aim to use encapsulation, for instance, so to have them hopefully from water and from chemical agents. Sweat is also chemical agent as well.
Mm-hmm.
So and in particular for the washing. For what concerns the interconnection, printing techniques or flexible circuits, which can withstand, let's say, mechanical stresses, but it is for the interconnection, not for the computation devices.
Perhaps the question is, you should divide in the system what part is fixed and what parts should be replaced. You know, all the screen printing for making two-dimensional materials, so printed two-dimensional material, in order to functionalize for measurements, for example, cortisol, it should be replaced because you know the life is it can be extended, but the degradation is quite fast in comparison with silicone.
Okay.
Thank you. Another question from the auditorium? Then I've got one. You mentioned that you're combining the fitness industry and health industry. What's very important because of the pieces that you're producing to make it more cheaper. But it's much harder to bring a medical device on the market than a fitness device, a consumer device. So how is this taken care of in this project?
Well, in the project, we are taking care of course, the aspects related with let's say the validation of the devices for the medical aspects, for the future steps. So higher TRL, not 5 or 6, but 8, 9, and so on. And for doing this, we are already paving the way because we have in our team the clinical experts, let's say the certifying committees, ethical committees, etc., etc. So we are already addressing this. Of course, we are pragmatic, and in the project we say we want to bring to maturity what we already have and pave the way to bringing into maturity the next. So this is also the reason why we have two, let's say, one more for innovation action project, which is bringing into let's say higher TRL what is already existing because we have this problem. It's true. On the other side, to prepare the approach also for the lower TRL that will be higher TRL in the future.
Okay, thanks a lot. We are in time. Thanks a lot for your very interesting presentation and for all the other also very interesting presentations. Do we have any announcement, Big Boss, to make now? Or can we just close this session?
So we will have some announcements on the last session.
Okay.
Because we have this evening tour before the dinner, and we'll announce you where we will meet. Because this is important, and then we have the dinner at the place that it's mentioned in the program. So you will see the restaurant, it's very close from here. So 8 o'clock we will be there. So the ones that will not join the walking tour will have to come directly at 8 o'clock to the base.
And the walking tour starts here at the
Starts, we will announce because we have to align with the local organizers.
But we have still 5 hours ahead of us.
Yes, yes. So we want you to participate in the next session as well. This is why we are keeping the secret.